Okay, so in this practice, write down the conditions for equilibriums of a ladder without considering the friction between the ladder and the wall. The ladder cannot maintain the equilibriums when theta is larger or equal to the 45 degrees. Find the coefficient of the static frictions between the floor and the ladders. So let's draw the free body diagrams first. So ladder and the wall and the floor. Then force is a normal force, N sub 2, and the friction, F, and the normal force from the wall, N sub 1, and the gravity, center of the gravity is located at the center of the ladders, is mg. So this length is L. This is half L over 2. Then angle of the ladder is theta. So this part, this is right angle. So this is pi over 2 plus theta. And then this is gonna be theta. Then we'd like to write down the conditions for the static equilibriums. For the sum of the force is 0. So this is for the horizontal conditions. N sub 1 equal F. So this is a horizontal force. The vertical force is N sub 2 equal mg. Really quite simple. From this equation, we could discover the magnitude of the normal force, two normal forces. And another condition is the torque is 0. The friction and N sub 2 starting from this point. Maybe it's easy to write down the equation for the torque if you choose that this is the axis of the rotation. Then we have to find out the direction of the axis rotation. For example, in this case, the direction is toward the board. This is the axis of the rotation. Then only the torque appears from the gravity and the N sub 1. Gravities is the length is L over 2 times gravitational force mg. And the angle is pi over 2 plus theta. So sine pi over 2 plus theta. This is the same directions with the axis of the rotation. It's directed toward the board. Directions for the torque is directed toward us. So we should put a negative sign. Negative. L is the length is L times N sub 1 times sine. In this case, the angle is pi minus theta equals 0. So this is sine pi over 2 plus theta is equal to the cosine theta. Sine pi minus theta equals sine theta. So in these equations, L appears both sides. Then from this equation, you have N sub 1. N sub 1 equal 1 over 2 mg cosine theta over sine theta. We have this equation. These three equations we obtain. Equation 1, equation 2, equation 3. For the static equilibriums, actually friction have to satisfy the conditions. Friction F have to be smaller or equal to the mu times n sub 2. Okay, this is a condition for the object doesn't move. Then n sub 2, you can use the equation number 2. For the f, you can use the equation 1. N sub 1 is the equation 3 you can use. Equation 1 and equation 3. Then you can write down the equation. This equation is 1 over 2 m sub mg cotangent theta is mu times mg. Then mg is going to be cancelled out. From these equations, mu is larger than the 1 over 2 cotangent theta. For the theta equal larger than the 45 degrees, the object starts moving. So mu is equal to 1 over 2 cotangent theta. You can substitute theta is 45 degrees. Then it becomes 1 over 2, 0.5. This is a coefficient of the static frictions. Okay, so this is the answer to these questions.